Hello, geometry students. Welcome back. Today we're going to cover section 1.2, which is going to give us some of our most basic postulates, theorems, and things like that. So these are pretty much rules that are known to be true in geometry. Eventually we're going to be doing proofs where you're going to have to use any postulates or theorems that you know to prove that a certain concept is true. So to start out, what is a postulate? So a postulate is a statement taken to be true without proof. So we'll see some examples of postulates here super soon. Let's write that down. So a statement to be true. Sorry guys, that's super messy. Without, so that's W/O, stands for without proof. Okay. A theorem is a statement that can be demonstrated true by mathematical operations. So, statement can be just going to abbreviate with W/ math operations. Okay, and then congruent segments is segments of equal length or distance. So congruent means equal. And you will learn when to use congruent and when to use equal very soon. But for now, just know that congruent means equal. So it's segments of equal length. So it gives you that example there. So you have segment AB and segment CD. So those little red dashes, that indicates that those are congruent. Also, the symbol for congruent, I'm just going to go ahead and write it down for you. And you'll see it below, but it's like an equal sign with a little squiggly above it. That means that they are congruent. So eventually you will learn that if you are talking about measure of something, so measure of an angle, you're going to do equal because it's a numeric value. Whereas if you're talking about just the segment itself, not the distance you're going to use congruence. But don't worry if that doesn't make sense yet. We're going to talk about that later. So it does show you here that if the segments are congruent, you can write the statement like that. Just another thing to point out to you if you haven't caught on to this. If it's just a line with no arrows, that's a segment. But if it has a line above it with arrows, that's a line. And then if you did your work with your dictionary, the very beginning of this notes packet, you'll know that there's also a ray. So that's where there's an arrow only on one end. So just to clarify that for you. The next section is the ruler postulate. So this is our first postulate. So remember that by definition, postulates are statements that are known to be true without proof. So this postulate, it says the points on a line can be matched one-to-one with real numbers. The real number that corresponds to a point is the coordinate of the point. The distance between points A and B, written as AB, is the absolute value of the difference of the coordinates of A and B. Okay, so what we mean by that, I know that's a mouthful, is let's say that these had like actual values. Let me Try to get this to stop moving for you for a second. There we go. Okay, sorry about that. So let's say that x1 was like -7 or something like that, and x2 was 7. If we're going to find the distance, we're going to subtract them, and it's going to be the absolute value of that. So you notice in the subtraction problem, you take x2 first, and then you subtract x1. So in this case, it's going to end up becoming positive anyway when you perform the subtraction. So you're going to have 7 minus 7, which is 14. But if it were -14, we would say it's positive. And the reason we use absolute value is we never would get out a ruler and measure something and say that it's a negative value. It's always positive. Okay, next piece is segment addition postulate. So the segment addition postulate, okay, it's still, is if B is between A and C, then AB plus BC is equal to AC. If AB plus BC is equal to AC, then B is between A and C. So it's just saying that we can add together the segment AB, so this segment to BC, and that equals the entire distance. So pretty obvious statement. So as an example for you, applying the segment addition postulate, the locations shown lie in a straight line. Find the distance from the starting point to the destination. So we know that we're going to be starting somewhere, and then we're going to stop at a rest area, and then we're going to start again and go to the destination. So to find the total distance, I have to add the distance of those two segments. So 64 plus 87. And if you go ahead and simplify that, that's going to be 151. And always use units, so it is miles. Awesome, so that is that whole page. So let's go ahead and turn the page. Come on, it's being a little wonky. Let me zoom out. Okay, got it. So the next part of this is going to be looking at segments and being able to determine the length. So it says use the diagram to find KL. So I know I'm looking for this distance here. This is my question mark. So I know that the entire distance is 38. And then I know that segment JK is 15. So to find segment KL, I know that 15 plus segment KL has to equal 38. So to solve this, I'm basically going to take JL minus JK, and that will equal KL, which is what I'm trying to solve for. So JL, the entire thing is 38, minus JK is 15, and we get 23. Okay, so that is example 2. Example 3, we're going to actually go in the coordinate plane. So it says plot these points, so I'm going to go ahead and do that. So J is -3, 4. So 1, 2, 3, 1, 2, 3, 4. K is 2, 4. Okay, and I should label them. L is 1, 3. Oops. We'll use that dot as L. And then M is 1, -2. Okay. Then they say determine whether JK and LM are congruent. So we're pretty lucky here that these are horizontal or vertical lines, because all we have to do is count the distance. So this one would be 1, 2, 3, 4, 5. And this one is 1, 2, 3, 4, 5. So yes, Both are 5 units. Just to practice our notation, JK is congruent to LM. All right, moving on. And ignore the numbering here. I just pulled some of the textbook problems. So this one says point S is between R and T on RT. Use the given information to write an equation in terms of X. Solve the equation, then find R, S, and ST. Okay, so we know that we've got a segment here. RT is the entire segment. So let's go ahead and do that. We also know S is somewhere in between R and T. We know that RS is 3x minus 16. So 3x minus 16 would go there. And then we know ST is 4x minus 8. And then we know the entire thing is 60. Okay, so going back to what are we trying to do? First thing, write an equation in terms of x. So I know that 3x minus 16 plus 4x minus 8 is 60. So that's going to be my equation. Then second step, solve the equation. So we'll combine like terms. So that's 7x minus 24 equals 60. Moving terms over, that would be 7x is equal to 84. So x would have to be 12. Okay, we're not quite done yet. Last thing they ask for is find R, S, and ST. So what I'm going to need to do is plug in 12 for x into each of those. So let's start with RS. So RS is 3 times 12 minus 16. So that is 36 minus 16, which is 20. And then ST is 4 times 12 minus 8. So 48 minus 8, which is 40. And then just to double check, 20 plus 40 is 60. So that looks great. We did it correctly. So my final answer here would be RS is 20, ST is 40. Okay. So then this last one, I'm going to let you try on your own. It's a challenge problem. It involves a little bit of probability, so it'll be a little bit of review from your earlier math classes. The answer is provided in the answer key, so you can just check your work there. So that's it for section 1.2.